Hi, my Algebra 2 kids. I just wanted to say thank you for joining me. Today we're going to be talking about quadratic functions. So this is going to be kind of a throwback to Algebra 1. And then we're going to, I hate how you can see my eyes. I'll do it without glasses. All right. So we're going to talk about, like I said, quadratic functions. This is going to be a throwback to Algebra 1 because you may remember talking about these. So let's just dive right in. All right. So quadratic function, what identifies something as a quadratic function? When you have f of x, or of course y equals, somewhere in there you have x squared. That is a quadratic function. It can have a whole bunch of other stuff attached to it, but that's what's going to tell us, hey, that's a quadratic function. You may even see that you have, at some point you'll see eventually a y squared in there as well. It wouldn't look like this though. It would be like y squared equals x squared, blah, 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 or it'd be set equal to 0. Those are circles, okay? Those are circles. We'll talk about those next semester, but for right now, just know that if you see x squared, you're gonna have a quadratic function. Now, if we graph a quadratic function, graphing a quadratic function means that we will end up with a shape called a parabola. And we talked about these in class, but just let's give you a quick refresh. Okay, so our parent graph is, maybe it'll help if I write it on here. So our parent graph is y equals x squared. That is the parent graph of a quadratic function. So then what we have, let me switch out my marker here so it's nice and bright. Okay, so then what we have, if we were to do this and we were to do an XY chart for it, we would end up with, I'm fixing my camera as I talk to you guys. Static. Okay, so we would end up with a parabola that looks like this. Start at 0, 0, we go over 1, up 1, over 2, and then again over 1, up 3. Nope, I'm off there. And then it flips to the other side, okay? Looks like this. There are parts to a parabola, and we're going to talk about each one of these. The first is the vertex, And so what I would do, guys, while you're listening to this video, grab a piece of paper, write down some notes on things that I say. If I say write it down, probably a good idea to write it down. And we'll kind of piece all this together in class, okay? First things first, the vertex is this, right? That's the turning point, all right? So our vertex is our turning point. Then what we have, I'm gonna write this down as we go along, vertex. Then what we have is our axis of symmetry. We abbreviate that as AOS. AOS, okay? The axis of symmetry is right in the middle here. This is where the vertex is. Axis of symmetry, I'm gonna come back over here. So vertex is your turning point. Turning point. Your axis of symmetry, this is written as x, y, your vertex, right? This is AOS. This is written as a line, And for right now, it will be written as x equals, and then whatever this x is from up here is gonna go here. For right now, next semester, we're gonna talk about parabolas that go open left and right, but for right now, we're just gonna stick with that, okay? So why is the vertex important? Well, if we can always use an XY chart in order to graph a function, right? However, if we don't know where our vertex is, we don't know where to graph. We don't know which numbers to pick. So we've got to figure out what that axis of symmetry is, okay? Now, the other part of it is opening, positive equals up, negative equals down. So we can tell if something is opening up or down based upon the negative or the positive that's at the very front of our quadratic function, right? So that's going to be important as well. And then minimum and maximum. Actually, we can attach this to the opening. If it opens up, it's going to have a minimum. If it opens down, it's going to have a maximum. And we'll get into more detail about these, but I think these are good notes to start with. Also, if you don't have graph paper, it's a good idea to get that so you're not having to sketch out a bunch of lines because we will be doing a significant amount of graphing this semester. Okay, so let's talk about how that works. Going back to our parent graph here, our axis of symmetry is x equals 0. So we write it as a line as x equals whatever. Our vertex is 0, 0, okay? This one opens up because it's positive. It's a positive x squared. And then it has a minimum, the minimum being where it goes all the way up, 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 up. But the minimum, the lowest it goes is right here, or 0, okay? So let's talk about some more of these guys. So let's talk about graphing graphing quadratic. Oh, actually, before we do that, I'm sorry. We're going to talk about the two forms of quadratic functions. Ugh, stumbling over my words. I'm sorry. Hang on one sec. Okay, so before we go any further, I had to make some adjustments here. What I want to do is practice that opening up or down, and if it's a minimum or a maximum. So what we're going to do is, I'm going to write these down, and you should, if you'd like to take notes so that you can practice these, that would be a great idea. If you just want to do it in your head, that's fine too. So we have y equals 0.5x squared. Another thing that you want to identify on these is going to be, well, we'll pause on that. Oh, God, I'm going back and forth. I'm so sorry, you guys. I get very excited about quadratics, and I want to tell you everything all at once, and I've got to remember not to do that. Okay, so what I want you to do now is pause now and or identify. You're going to pause the video. You're going to identify what its vertex is, right? All of these are going to be 0, 0 because we haven't gotten any further than that. But I want you to identify if it opens up or down, or if it has a minimum or maximum. So go ahead and pause and then come on back. Okay, so taking a look at this one, this is a negative, so this is going to open down, right? And so that's going to have a maximum. And we'll figure out what those maximums are in a bit. I just want you to get real familiar with these. Taking a look at this one, this is also down, so it is going to have a maximum. Looking at this guy's positive, so this is going to open up and it's going to have a minimum. Okay, and again, all of these, their vertex is going to be 0, 0. This is going to open down. Oh, I'm sorry, up. I was looking at the one below it. I'm sorry. This is going to open up, and this is going to have a minimum. This one is going to open down, and it's going to have a maximum. And this one is going to open up, and it's going to have a minimum. Okay, so here's the other thing that you're going to want to write down with these. So go back to your notes and write down less than 1, fat. Greater than 1, skinny. Yeah, I have to think about that. Greater than 1 is skinny, okay? What do I mean by that? Take a look at these example problems here, okay? This guy, and I'm not talking about the negative sign, I'm actually just talking about the number. So this is greater than 1, so it's going to be a super skinny graph when we go to graph it. This guy is greater than 1, so it's going to be a super skinny graph. This guy, less than 1, so this is going to be fatter than our parent graph, which is over 1 up 1, over 1 up 3, right? So this is going to be fatter. This will be skinny, and this looks like a fraction, so you think it's less than 1, but remember, it's actually 1.5, right? This is an improper fraction. So this one is also going to be skinny, or it's going to be, oh, I just messed myself up. It's going to be skinny. Okay, so all these guys are going to be skinny except for this one, okay? And that'll make a little bit more sense once we start graphing these guys. Now, that's what I want to get into. Let's start graphing these. Let's look at, actually, let's practice that fat and skinny. Fat and skinny. You shouldn't say fat and skinny. I think you're supposed to say wide and narrow. So I jump between the two. I apologize. But if I say wide, I mean fat. If I say narrow, I mean skinny. Okay, for example, if we have y equals x squared, then we have y equals 5x squared, and then we have y equals 3x squared. From the skinniest to the fattest, right? Well, this is going to be our skinniest one is going to be this guy right here, okay? Our next skinny one is going to be this, and our third skinny one is going to be this guy right here. Because again, the further away from 1 we are, the skinnier it's going to be. So let's try another one. I'll write these down and then I'll have you pause and give that a shot. Now, again, I don't care about opening up or down for this purpose. I just want to know, start with your skinniest and then go up to your fattest. Oh, shoot. Did I write that right? Yeah. X squared. And y equals negative x squared. Okay, so pause the video and tell me which is the fattest or skinniest, and then go up to the fattest, right? Okay, so if you paused it and let's double check your work, this is gonna be our skinniest one, right? After that comes this guy here, because that equals 1. This guy right here is less than 1, so it's gonna be our skinniest, or our fattest. God, I'm messing those up, I'm sorry. But that will be our fattest because it's less than 1. Okay, so now we're gonna try graphing some of these guys, okay? So what I'm gonna show you are this first one, and I'm gonna try and, let's get this down a little bit closer. Okay, so the first one that we're gonna do is gonna be y equals x squared. Now, I told you this one earlier. We go start at 0, 0, we go over 1, up 1, over 1, up 3. And that axis of symmetry just says that it reflects across to the other side. So we can make it copy like by going like this. Over 1, up 1, over 1, up 3, okay? That's our parent graph here. Looks like this guy. Okay, so now let's try graphing y equals 4x squared, all right? Now to do that, we're gonna do an xy chart. And we know for all of these, because I haven't told you how to find your axis, or I'm sorry, your vertex yet, it's all gonna be at 0, 0. So we can pick -2, -1, 0, 1, and 2. Well, we know if we have 0, that's gonna be just 0, right? Maybe I'll have Fight go up a little bit higher. Okay, so we know that that's just gonna be 0. So I'm gonna put a 0 right there. Then we know for +1, if we put that in here, we're gonna get 4. For +2, that's 4, that's gonna be 16. Now, it's gonna be reflected on the same side. -1 squared is quantity -1 squared. Remember, there's a big difference between that and this, so make sure that you're using your parentheses. That's gonna be 4 times 1, which is 4, and then -2 squared is gonna be 4, and that's gonna give us 16, okay? So what we have for our second graph then is y equals 4x squared, right? So we're gonna go start at 0, 0, but then we go over 1, up 4. Then we go over 2, up 16. So when we get there, that looks like this guy right here. Let me finish drawing it and I'll show you. Okay, so for that guy right here, do you see how it's much skinnier? That's because it is larger than 1. That's where I keep tripping up on my words on that, because you would think that if it was small, it would be skinny, right? And then the larger the number, it would be fatter, but it's actually reversed, okay? So let's try practicing graphing. Actually, what I'd like you to do is you're gonna use our same domain. Remember, domain just means x. And I want you to try graphing y, pause the video and graph y equals 1/2 x squared. Y equals 1/2 x squared. Okay, so hopefully you've come back from that. You did an XY chart. Let's do it together and see how you got. All right, if we plug in 0 here, we get the 0. If we plug in 1, we get 1/2. If we plug in 2, that's 4. Half of 4 would give us 2. And then -1 would be 1, so that's 1/2. -2 squared is 4, and half of 4 is 2. All right, so we have 0, 0, okay? And then we have over 1, over 1, 1/2, and then over 2, up 4, or up 2, sorry, can't read. Over -1, up 1/2, over 2, up 2. Okay, so now you can see how that one is much fatter or wider from our parent graph, right? So now you're able to look at these and say, okay, is it gonna be fat or skinny, right? So previously I talked a little bit about how we manipulate these graphs, up and down, left and right. We're gonna touch base on that as well. So let's see. I like to say a lot when I do this. All right, y equals x squared plus 8, okay? This is gonna tell us to go up or down, depending on if it's positive or negative, right? So this just tells us that it's that parent graph, that original graph. Over 1, up 1, over 1, up 3, over 1, up 1, over 1, up 3, right? It looks like this, except we're going up 8. So we're gonna start up here at 8, and we're gonna go over 1, up 1, over 1, up 3, over 1, up 1, over 1, up 3, just like that. And there we have graphed that guy, okay? So, so keeping that in mind, what I would like you to do is go ahead and pause the video and graph y equals 1/2 x squared minus 3. Okay? So, and you'll want to make an XY chart for this, but you know that it is going to go down 3. Okay? So hopefully you pause the video, graph that, use your XY chart, and come on back. Okay, so starting at this, we know it's going to start down here at -3. And I know this because if I do an XY chart, I always start with 0. And again, your XY chart can totally be out of order. It's not the end of the world. 0 here, anything times 0 is 0, right? So I get -3, all right? Well, if I do 1 here, I get 1/2 minus 3. That's going to be -2 and 1/2, right? Because I took 1/2 away from, so hopefully that's making sense without having to convert it all and all that good stuff. All right, so then 2, if I do 2 here, that's 4. 1/2 of 4 is 2. 2 minus 3 is going to give me -1, okay? So that's over 1 down 2.5, which is right here, over 2 down -1. Okay, let's try our -1 now. -1. So if I do -1 here, that's just going to make this 1/2, and that's going to, again, give us -2.5. If I do a -2 here, same idea. I'm going to get +4, and 1/2 of 4 is 2, minus 3 is -1. So I go over this way and down, and then I go over 2 and down 1 right there. So again, we can see that that's going to be a fatter graph than our normal parent graph, and that it went down 3. Okay, hopefully that's making a little bit of sense. And we'll practice all of these in class. I just want you to be real familiar with it. Okay, so then the other thing that I want to talk about is going to be standard equation, or standard form of a quadratic equation. You'll want to write this down. Is going to be ax squared plus bx plus c. Okay, vertex form is a little bit more than just what we talked about, which is a, and then we've got x minus h squared plus k, hk, yes. So y equals that, y equals that. And in our vertex form, remember I just said that this is like our up, down, right? So this is going to be up, down. This is going to be do the opposite, left, right. Okay, so I just wanted to make sure you had that written down. All right, so standard form and vertex form. All right, go ahead and write those guys down, and we will do a couple practice ones for those. And then a positive A, remember, on both standard and vertex form. Positive A equals up. Negative, opens up, I should say, opens up. Negative A equals opens down. And this goes along with our greater than 1 is going to be skinny, right? Greater than 1. If A is greater than 1, it's going to be skinny. If A is less than 1, it's going to be fat. Okay, so knowing all of this, we're going to practice some of these guys in vertex form, all right? So, for example, we have y equals 2x minus 1 squared plus 1. The vertex of this guy would be opposite this, regular this, okay? So our vertex is going to be 1, 1, all right? So now what I'm going to want you to do is identify the vertex for these guys. 2x plus 4 squared minus 1. Okay, so we're going to identify the vertex of these guys, right? For this guy, we're going to do, again, opposite this, regular this. So that's -4, 1. Opposite this, -4, regular this, -1. No, again, knowing that vertex means now we can go out and do an XY chart and plug and chug some numbers on either side of our vertex, right? So identifying the vertex is the biggest thing that you want to do. I love it when they're in vertex form because it's right there for you, right? So we're going to start with this top one here. And I've got this in vertex form, right? So I know that my vertex is going to be 1, 1, right? Vertex is going to be 1, 1. Now, the other thing we talked about is the axis of symmetry. Our axis of symmetry is written always, AOS, like a line, and it is x equals, and it's whatever the vertex is, whatever this first one, that's this here. Oh, I almost wrote 1 again, or x again. So it's going to be a 1, okay? So now, when I take this information and I go back out to my graph, I've got our vertex is 1, 1, which is right here, okay? And my axis of symmetry is right along there, x equals 1, just like this. And this means whatever happens on one side is going to happen on the other. So now I'm in a position to use an XY chart. For making this easier, I'll just write this back over here so that we have it. So I have to flip between these two things. Okay, so for an XY chart, we're going to do X, Y. Since it's at 1, 1, I'm going to pick two numbers. How about 0 and -1? I'm lazy. I always pick the one with 0. So 0 and -1, because what happens on this side is also going to happen on this side. So if I go back up here and I plug in 0 here, I get -1 squared. Quantity -1 squared is just 1. 1 times 2 is going to be 2 plus 1 is 3. So if I have 0, if x is 0, y is 3. Now let's try -1, and I'm going to write this one down just to be a little bit safer. I hate to make a stupid mistake on this as I'm doing it. Okay, so add the opposite. So 2 times -2 squared plus 1. -2 squared is going to give me 4. Times that by that, it's 8 plus 1 is 9. So -1 is 9. Okay, so now let's go back out to our chart. We know that this is our vertex, and if I go to 0, I go over 0, up 3. I go over -1, I go up 9. Well, knowing that we know the vertex or the axis of symmetry, we can now copy it on the other side. So I can just go right over here and then right over here and kablam. Now, the reason why I taught you does it open up or down and is it fat or skinny is that's a check on you. You can look at that now and say, okay, yes, it's supposed to be skinny because it's greater than 1 and it's supposed to be opening up. So this is you just double checking your work, right? And looking for those patterns that can kind of help you. Okay, so why don't you go ahead and I would like to see you graph or give it a shot to graph y equals -x plus 4 squared minus 4. Identify your, didn't help, did it? Identify your vertex, and then your axis of symmetry. Okay, give you a minute to do that. Good, if you need more time, pause the video, but our vertex is gonna be opposite this guy, regular this. So -4, I'm sorry, you can't really see that. -4, -4. Axis of symmetry, again, always written like a line, x equals, and it's whatever your x is on your vertex. X equals -4. So that point, -4, -4, that's all the way over here. There we go. That's this guy right here, okay? To make it a little bit easier, I'm gonna recopy this equation down here so that we have it. Okay, so now that we know it's here, what we're gonna do is pick two numbers on either side. Like I can either pick -3, -2, or I can pick -5, -6, okay? So, let's see. Why, that's the smoke detector going off in my house. I'm so sorry. Let me figure that out. Okay, so, all right, so we know that this is, we've got our vertex here. So like I was saying, you either want to pick -3, -2, or -5, -6, because what happens on one side is going to happen on the other. So let me do an XY chart here. Now, the other thing we know is this is a negative, right? So this guy should be opening down, So I'm going to pick -3, -2, and see what happens. All right, so -3 plus 4 is 1, right? 1 squared is 1, so I get -1. And let me go through that whole thing just in case you're a little bit weak on your algebra. So -3 plus 4 squared minus 4. -3 plus 4 is 1, right? So I get -1 squared minus 4. 1 squared is 1, so I get negative 1 minus 4, okay? That's negative 5, right? So I get negative 5 here for negative 3. Now we're going to do the same thing for negative 2. So negative 2 plus 4 squared minus 4. Negative 2 plus 4 is going to be 2. So I get negative 2 squared minus 4. 2 squared is 4, so that's going to be negative 4 minus 4, which gives me negative 8. All right, so for negative 3, I come over here and I go down to negative 5. Then for negative 2, I go down to 8. Good, and we've established that our axis of symmetry, sorry, my camera's not as big. Our axis of symmetry is negative 4, which means what happens on one side stays on that side, flips over to the other side. So that's why I chose those two numbers, because now I can put it over here and put it over here. Now again, that A here was 1, so you'll notice that pattern, over 1, down 1, over 1, down 3. That's that parent graph pattern. And it looks like this. All right, so good. Any questions on these? We will practice these in class. I just wanted to give you an introduction to graphing these guys. And then I'm going to do a couple more videos for you that have diving into quadratics a little bit more. So thank you so much for joining me. Excellent work, and we'll work on these in class.